Welcome to the Earthworks podcast, where our team will share the jargon of carbon from many of our turf friends from the past 30 years.
Hi, everybody. This is Joel Simmons, and this is the Earthworks podcast. And I'm very excited to have two gentlemen from the Turf Drainage Company of America, Dennis Hurley and Zach Boudreaux. And Dennis, you and I go back quite a ways. We have a mutual friend in Mr. Don Nauman together, which is unfortunate. And I think my first memories of you were on a float in New Orleans.
I believe that's right. What you can remember of it.
That's the little bit I remember. Dennis is, both of you folks are in and live in and are from New Orleans. So Dennis, I guess you've been on the float for a long time, and I took your spot actually I think I've been on that float 3 times. Of course, my brain cell has since been lost, and I have many goofy pictures of me in costume, but I am very grateful for you for that experience. It's 1 in a lifetime, or 3 in a lifetime for me, but that's not why we're on the Earthworks podcast today. So
yeah, I did give up after about 12 years. Nauman's still going after 25.
Yeah, he's a crazy man. And he's now moved up to the upper deck, I understand.
Yeah, he'll be running the organization soon.
Yeah, I'm sure he will be. But all I remember is I spent a lot of money on beads, and I remember the guy next to me the first year brought in moonshine and had a big bucket of moonshine, and I think he was arrested halfway down the trail, and if not, had some issues keeping everything down. But it was quite the experience for me, and it was interesting. Then when we pulled into the Superdome and saw that party, which is what the
largest private party isn't it, Zach, in the world? I think that's how they sell it. Yeah.
It's quite the experience, and it was quite a time. And needless to say, New Orleans is a phenomenal place to spend some time. So let's get into this, Dennis. You have been doing this since 1984. The Turf Drainage Company America is known for what everybody in the industry would know as turf drain. Tell me about how you got into this. I know you were in chemical sales. You were doing some stuff before then, but you're actually older than Earthworks, which is, it's I always find amazing.
Is that older than dirt? Guys. Is that older than dirt?
Right. Yeah, older than dirt, and that's what we are. Yeah.
So I was a chemical and fertilizer distributor, seed, covered Louisiana, Mississippi, Texas, and really stumbled into the drainage business. We were carrying a product for erosion control, started getting into some of that type of construction stuff, and stumbled on a product that was patented at the University of Connecticut for foundations of buildings. And it was made in 5-foot sheets. And we went to that company and asked them for a marketing agreement to cut it down in size and to use it as a replacement for perforated pipe.
What year was this, Dennis? What year was that?
That was 84 when we started.
That was right when you starting this thing. So what was the vision? I mean, you saw this material and you said, hey, this would be great for drainage in a golf course?
Yeah, I didn't know how to spell drainage, actually. It's really,
now?
I hope so. Back in those days, there wasn't any internet. So I had to, I was out there selling this new concept. And this concept was developed by an engineer, and it followed basic seepage and drainage principles, which is a kind of a specialty field in engineering. A lot of civil engineers don't even know some of the formulas and stuff that are used in that. So I was being told stuff by the people that had developed this as to what the benefits were, and I'm out there trying to sell it in golf courses and needed to learn more. So Tulane University had a engineering library, and I still have the copies. I went down to that library, and I couldn't check any books out. I wasn't a student, but I would go in there and Xerox the engineering.
Wait, nobody knows what Xerox means, Dennis.
Yeah, exactly.
Zach doesn't even know what that means.
Yeah, so I would go into these chapters and record all that stuff and copy it and go home and read it at night, and that's really how I was getting really just trying to get the information so I could give the right answer and give the explanation that I was being told by an engineer, but didn't really quite understand. So anyway, it progressed from there. Started with that one product. The idea was, I knew the chemical and fertilizer business. I thought the best way to sell it was going to be through chemical and fertilizer distributors. Thought they were really, compared to, let's say, equipment salespeople, I thought they would have a better penetration for that type of product. And I went around the country for a couple years, setting up chemical and fertilizer distributors to go out and call on golf courses. And it was fine, but it became a little more technical and a little more involved than the average chemical and fertilizer, because they were kind of getting away from their basic, just like I was when I started it, but they didn't have the incentive, I guess, to really delve into it. So the one guy we have left that still distributes, that we sell through distribution, is Don Nauman up there in Northern California.
Sierra Pacific Turf Supply in California.
Yes, sir. Yeah. And,
Dennis, let me go back. I'm fascinated by this, but so you're sitting there looking at this patent from Connecticut, and you turn this into a need and into a value-added a service thing. I mean, what was the environment like at the time? I mean, what made you think that this would work on a golf course? I mean, that sounds like a pretty big leap, especially if you have to go into a library and study it for a couple of weeks.
Like most people, when I first introduced it, and I guess even my probably initial concept was, you were going to be able to dig a narrower trench. It was a vertical material, it was 1 inch wide, 6 feet tall. And in the early days, we went out and promoted that, and we had a special trencher that
less disruption.
Yes, but that really kind of went by the wayside once we understood more of it. And really, the benefit of the product is it's a much better collector of water. It has a perforated pipe where it collects the waters through the perforations, 3.5 square inches of open space per linear foot. This concept has 153 square inches of open space per linear foot, so 45 times the collection space. The big difference was, back in those days, this is in the early days of geotextiles just really getting started. Geotextiles have started in the highway business, and people are still trying to learn how to use them. And that's really where it became, this is much easier to build a technically correct system. So back in the just 7-8 years before that, before geotextiles came out, the presentations we used to do, that if you were going to build a seepage drainage, this is out of the seepage engineering books, for a dam or a highway where somebody could lose their life if it failed, you built what was called a multi-layer system. And that multi-layer system had just kind of like a USGA green, in that it had these layers. So you had, in the USGA greens concept, you had the greens mix, you had a choker sand layer, you have a gravel blanket. That was based upon the principle is, you don't want the D85 or the 15th largest particle of one layer moving into the other.
Right.
Well, as difficult as, and the USGA have eventually modified and adopted what's called the Terzaghi formula, which is what we talked about from the early days once we understood the principle. And we have a presentation, a webinar on our website now if somebody wants to get into the details of this. But in general, in vertical trench construction, as difficult as it is to put those layers in a green, it's almost impossible to put it in a trench. And that's what the highway document said, is that we find these designs on a lot of plans, but they very seldom are installed properly in the field. Now, this is back in the late 70s. So the use of geotextiles gave the industry a way that they could meet these formulas and not have the contamination of the gravel that you have if gravel is up against the material where the D85 can move. And we do that by eliminating the gravel. We use sand as the backfill because that has a smaller opening, and it So it is a stable system, and the sand in combination with the geotextile is by far the simplest way to build a technically correct seepage system. Now, still to this day, the majority of drainage that goes in golf courses still has perforated pipe and gravel. But if you go out and you use that same gravel, you're on a hole, you're building a USGA green, you sent your mix in, tested the D85, everything matches up, that gravel's good to go for that greens mix. You take that same gravel and you put it out in the fairway and match it up to the native soils, you're going to have that gravel's going to fail because of the 15th largest particle in the native soil is much smaller than it is in sand. So in basically almost all golf courses, maybe Pinehurst, maybe Cypress, you could find native soils that can match up to gravels. But 99% of the golf courses, the proper backfill is sand along the trench wall, and then you use to match up to the geotextile and build a technically correct system.
So is it common in almost all golf courses nowadays to have some level of geotextile in their
No, like I say, you'll still see a lot of perforated pipe and gravel.
Yeah.
No, it's
and if I can,
I'm sorry.
Yeah, jump in, Zach.
Geotextiles seem to have gotten a little bit of a bad name, in some regard as it relates to drainage, but because they're misunderstood and misused, a lot of times, when geotextiles fail, it's because that same concept of the particle size distribution matching. When you size a geotextile to a soil, it's very difficult to do on a golf hole and almost impossible to do across a property because soils are different in different parts of the property. So what we have found is that using the geotextile with a known particle, like a coarse sand, we can match and bridge the geotextile to the sand, and the sand bridges to the native soil. So the concept that Dennis has, made, we're becoming to get more standard, but what we use is the geotextile does not touch the native soil, so the native soil cannot compromise it.
That makes sense. So you're bringing in sand, and then everything is going through the sand into the textile, and then you're finding an exit strategy for
right.
Yeah.
And it's important to note that draining a green is a different concept than draining a native soil. Draining a bunker is a different concept to draining a native soil. It's different mediums, it's different directions of flows.
Explain the difference between.
Let me add one other thing. As you look back at the history, before we got to that part of the market, perforated pipe had started using a sock. But so people
just to keep it clean.
So this again, they were trying to learn how to use geotextile. So when we introduced our material, they said, well, we tried that sock pipe and it failed. And so always the question was, well, how'd you use it? So we put the sock pipe in the gravel. So what happened was, because the gravel didn't match up to this particle sizing of the trench wall, the native soil, it wasn't a stable system. So the fines would move through the gravel. They would accumulate on the outside of the sock. The system would fail, and the people would blame it on the geotextile. But the failure was at the interface of the sand and the trench wall, not at the sock. If the sock would so the difference then between our material and if you commit to sock pipe and you use it with sand, then you're building a technically correct system. But then the difference with our material is we have so much more collection space, as I mentioned earlier, as far as the square.
So what happens with the fines in your material? I mean, wouldn't it?
They're stable. So you stop the D85 in the native soil doesn't. So the Terzaghi formula, and again, we have a webinar on we have 7 or 8 TurfNet webinars we've done, but the understanding the principles of seepage drainage. If anybody is having trouble sleeping at night, it's up for you to watch. But so the Terzaghi formula it calls out what that relationship it should be between the D85 and the D15 of the material that's up against it. So you don't want it more than a 4 to 5 times difference. So by using that smaller opening of the sand, the native soil, the D85, is held in place, and only the water can move.
Dennis, just so those of us who are novice here understand this, explain D85, D15, just so we all understand it.
You got a range of particles from 1 to 100. If you
sand particles we're talking
soil,
about.
Yeah, every soil would have a different, D85 would be a different size in sand than would clay. But what you're talking about is if you're going to test it, you're going to test
Right.
the Terzaghi formula says, and this is since 1940, developed it by Carl Terzaghi he was at Harvard and MIT, and it's the basis of all seepage and drainage engineering. It's the basis. It's how they build dams, runways, and that type
So
of
this
thing.
is basic civil engineering.
Yeah,
This is what you were learning in the library that night when you were hanging out until midnight?
Oh, it was a lot more than a night or two, but no, it's in this specialty field of seepage engineering.
Yeah,
yes.
yeah. Interesting. Zach, as a national account manager, explain to me the process now. I'm a golf course superintendent. Clearly my need is, and correct me if I'm wrong, I'm assuming, and I could be dead wrong, so stop me if I am, that majority of your business is fairways on the golf course?
Yes, I mean, the turf drain that Dennis talked about, it has an application in all areas, but if you're building the technically correct USGA green, we're proponents of a USGA green, and we feel like, perforated pipe is suitable for a USGA green, but no, our product is used in bunkers as well,
Right.
with liners, but mostly fairways and roughs is obviously where the most acreage is on the golf course.
So what's the process? I'm a superintendent. I'm getting pissed off because I'm always having a problem getting carts out because it's always wet and gooey, and obviously I'm having a trouble growing turf. And
yes,
I mean, I spend a lot of time, and you guys know this, but I follow the three-legged stool model: chemistry, physics, biology. Chemistry affects physics, which affects biology. Obviously, Earthworks is focused on biology, but you're in that middle leg. You're in that physics leg, and you're in the tough part of it, because even though we think that we can manage or flocculate a soil by managing chemistry, and this gets me into a lot of trouble with our friends in the BS world, but we can flocculate soils with certain things like calcium. Sorry, Travis, but it's it's these heavy soils that you just need to really take it to the next step. So you guys really fill that middle leg of physics. And so I'm sitting here as a superintendent struggling with keeping my fairways from draining, and this is a solution that really solves that problem. What's the process when I call you guys out, Zach? What do you what do you do when you get to my property? What's the process of?
Yeah, I mean,
all out?
there's really, a spectrum of levels of involvement, and we're always happy to just start with an introductory conversation, talking to a superintendent, kind of understanding what his issues are. If it's something small that he wants to take on in-house, we're happy to talk guys through that. But the vast majority of projects that we get involved in, we push to come into a property and do a drainage plan for a superintendent. We come in and look at a number of holes, or 18 holes of the golf course, and we actually walk every part of that golf course with the superintendent and try to really get a good handle on what's going on there, and what their goals are. Every property has varying goals, whether you're having a tour event, top tier amateur tournament, you're a blue chip country club that wants prime conditions every day, or you're a municipal course that wants to get carts out and just wants to be able to mow and maintain. So there is no one size fits all solution. When we hear some people, when they think in terms of drainage plan, they look at acreage, assume you're going to need so much pipe for so much acreage, and let's put a number at it on a given spacing. That is not what we do. Every property is different. Every golf hole is different. Parts of a golf hole are different. When Dennis talked about seepage water, one of the ways that we're oddballs is that even when we're talking about seepage water, we classify seepage water 3 different ways. So we really drill down and take a narrow approach looking at these issues. But again, we like to go in and do a drainage plan, walk the property for a couple of days with the superintendent, collect data, GPS points, locate basins, budget given amount of seepage pipe for a given area. And then from there, we'll deliver an actual plan outlining what solution we're proposing and applying a cost to the installation, though that's becoming more of a moving target in this economic environment.
I was going to ask you that, but maybe I don't want to.
No,
maybe you don't want to talk about it. I'm sure the cost of living these days isn't helping you much.
No, but, and, some clubs decide once we deliver a plan, they'll, the rare cases that they take it on and say, okay, come to our property and drain the golf course start to finish. More often than not, it's a phased approach where a club will say, okay, we want to take on our 3 worst holes,
Right.
in the next year, and let's prove up the system to the membership. And then from there,
Yeah.
go on.
I mean, do you often have a golf course just ask for a single fairway to drain just that area, or one area? That's
Yeah, we do, and we're
relevant?
happy to do that. But when we, we're based in a town, and
Yeah.
we have reps in different parts of the country, but we're traveling. What we try to do is when we go to a property, we'll plan as much as we can in one day.
Right.
For a guy for economics.
So let's get into. So now I've said to you guys, yeah, let's do this. What happens? Turn off your phone there, Dennis.
I had it off, but it came up on my.
That's all right. It's a live recording. But anyway, Zach, let's get into. I mean, now you're on property. How disruptive is this process compared to using perforated pipe? And are they even still using perforated pipe in a fairway drainage process?
Sure. I mean, perforated pipe is the industry standard seepage component. So but it's a commodity. We look at ourselves more of a technology, and we're bringing a solution. But no, I mean, the guys are putting in perforated pipe every day. Perforated pipe isn't going anywhere. Right. But as far as disruption, installing a drainage system on a golf course pretty much is the most, aside from mass earthwork, is pretty much the most disruptive thing you can do. Because, if we compare it to irrigation, you're digging a trench, putting a pipe in, and pushing that same soil back in the trench.
Right.
With drainage, and when you're working on an existing golf course, you're stripping sod and setting it off. You're doing trenching operations, then you have to remove those spoils, then you have to bring in a backfill material, backfill, compact, replace sod. So it's a disruptive process, but it can be done a hole at a time. When we go in, most of our work is on existing golf courses, and we try to only close a hole at a time, strip sod, replace sod, and once it's healed up to the superintendent's satisfaction, he can open it back up, and we'll move on to the next hole.
What's typical time frame for a one hole operation? One fairway?
It depends. Depends on the
because
hole.
of the soil. Is that what's the limiting factor? What is
it can be. And when we talk about soils, I know this is your department, but we hear a lot of time, we just got a tight soil, tough soil that can't be drained. We think that we can drain almost any soil. Now, the logistics of getting that soil out of the trench is a different story. When you get into some really tight clays and gumbos, some of the stuff we have here in New Orleans.
Yeah.
Dennis talks a lot about the eastern part of the Bay Area in California as being some of the worst in the country. But
yes,
no,
the golf courses.
Right. The logistics of moving the material, I mean, is a big determining factor of the time. And our motto is kind of plan when it's at its wettest and install when it's at its driest. Obviously, the better work conditions we can get, the quicker it goes, but it can vary. I mean, it depends on the demand of a hole, but it could take, you could drain a hole in a couple of days if it's small, or several weeks if it's, par 5 with serious issues.
Yeah. I would think doing this work when the soil's wet would be very difficult for you guys.
Oh yeah.
But isn't that why you're there? Because the soil's wet? I mean, isn't that a common practice in your world?
Right. But, depending on geography, you'll tend to have a typically, drier season throughout the year. But the other challenge is, in the Northeast, and, where golf is a seasonal thing, guys want to be playing during the season, and they want to work on the shoulders. And, then you have the spring snow melt, then you have the fall cooling and wet season. So does present a challenge.
It's never easy, is it? It's just always something, right?
No.
Do you guys, this is a self-serving question, but do you guys, you don't really care about soil type? I mean, about like, you don't run soil tests before you do any of this. You're just digging holes. You don't care about soil chemistry is what I'm asking.
Yeah, no, that's right. Now, it's not that we don't care and that it doesn't have an effect. So when we go through this planning process, we choose a seepage field size for every individual site. And there's different factors that determine that: the slope, the part of the country we're in, the rainfall, what we're being told as far as how bad things are when it says it's worse, what we can do in other sites to affect the site below it, and the soil type. So if we know that a clay soil doesn't have the permeability of a sand, so it becomes a factor in the size of the field, which determines the intensity. So there, a lot of other drainage companies have a very standard width when they put in pipe.
Spacing.
They might put it on 10-foot centers. Some other types of methods actually use as small as 6-foot centers, some 15, and it's a constant. Ours do not have that constant. So what we go through when we go through that planning process, that is subjective. We don't want to put more than is needed because you can only get the soil down to field capacity.
Right.
We're just wasting their money if we put more drainage in than we can only drain gravitational water. But if we don't put in enough, then we don't meet their objectives. But that is the subjective part of it. It's not an exact science, but it's based upon what we do every day. And the soil type is one of the factors we use to determine the intensity.
Yeah.
Yes.
I mean, my job here is to ask the stupid question, so I'm going to just continue to do that. But I would think in these really tight clay soils, and I'm sure you guys have worked in a ton of them across the country. I mean, the water's not moving laterally very well, is it? I mean, and if that's the case, are these drains only catching what's coming down the drain line?
Here's the thing that most people, the most misunderstood part of what we do is, and I mean, I've read it in books that are golf course books and about drainage and about the limited effect you can get from seepage drainage because of the low permeability of the clay and how far away the influence is. But what most people don't think about is if you're, let's say, working on a hillside, and it was always interesting when we got out to California, is that the wettest holes were the ones that had some elevation change to it. It was these long watersheds where water was coming down these hillsides. And the average person, if you ask them, if you got multiple lines going down this hillside and you're standing on a line, that guy's thinking that line is there to drain the water that's above it, which it is. But one of the most important principles in drainage is what's called concentrations of flow. Now, sometimes you want to reduce concentrations of flow, sometimes you want to increase concentrations of flow. But the lowest part of the watershed is always the wettest. It gets the same amount of rainfall as the upper part, but it has to deal with the water that fell at the upper part of the watershed as well as what fell on it. So our drainage is it is about permeabilities, but it is more important to understand when to reduce concentrations of flow. We do that in two different ways. We can do it by getting surface water off of the upper part of the watershed. So if we're out doing a plan and a guy tells me we are soaked down here, when it gets wet, we're a shoe loser. And I start walking up the hill or up in the rough or up along the boundary line. And he said, no, look, we're okay up there. It's not a problem. It's here's where we're wet. Right. But the first thing we're looking for is the upper part of that watershed. How do we reduce that concentration of flow? Now we have a method. We manufacture different types of basins that we patented, but the one is specifically designed to identify these streaming areas on a golf course. So when we walk that's why we can't do it on Google Earth. When we walk these golf courses and do these plans, every golf course has these areas where flow pinches and then it widens back out to sheet flow and then narrower stream flow. We go through and we identify where these areas get their narrowest flow area so that we can have the most effective collection of that water that's still on the surface. And we do that with an inlet. The seepage line then does the exact same thing. But you can't drain a golf course with just surface collection. You're going to have water that gets trapped in the profile. The water that gets trapped in that profile and that low permeability soil that everybody feels, well, I'm not going to get any movement from this. But if you walk down a slope where you see multiple turf drain lines, that line is protecting the area below it. Right.
So you're catching it before it gets there.
That's right. You're reducing the accumulation.
And this is the key concept that we try to employ when we're going out and doing plans. Every property requires, because of its slope, geography, soil type, every given property fall somewhere in the spectrum of needing surface versus seepage. Every property needs some degree of surface and seepage, but a hillside property is probably going to need more surface collection, and a flat property is probably going to need more seepage collection, all things being equal. Like Dennis saying, what we don't want to do is just go out to a property, look at the wet spot, and throw a bunch of pipe in it. The key to getting the golf course back in play as quickly as possible following the rain event is not letting it become as wet as it otherwise would. So when we're walking and looking at these areas out of play and looking at positions to put inlets, that is the point. We want to collect that water before it ever gets down onto the turf as much as possible.
So depending on the soil type and where you are, you could have multiple basins within that area you're describing, that collection area.
Sure. I mean, we go out and do plans, and sometimes a watershed may have 3 or 4 golf holes going across it from top to bottom. And we want to get as many collection points as possible in that watershed. The more that we can do higher, the less pressure there is in the very bottom of the watershed.
So what's the process? You get onto a property and you just start walking?
Walking.
How do you know where what if it's dry, or you're in, like, if you would have come here to the Northeast this summer to do a drainage line, because my fairway's been wet forever. We hadn't had rain in 90 days here in the Northeast. I mean, how would you figure out, where my problems are if you were to go into a situation like that?
Well, that's why we need the guys that are on the ground there every single day to tell us. That's why they're there.
So you're relying on history of their expertise.
Right. But ideally we get both. We want to come when it's wet. But if it's not wet, we need you telling us where the difficult spots are, what the problems are like,
Yeah. So again, my job is stupid questions. Where's the water go?
Go ahead, Dennis.
Let me expand, if I can, just backtrack just a hair on what Zach was saying there about protecting the golf course. We've got a picture on our website of one of our channel drains, and it's a picture at Valhalla, the 9th hole. The first year we worked there, and we worked there for, what was it, Zach, 8 or 9 years, I guess, before we finished the entire plan. But the first year we worked there was the year Rory won the PGA. I don't think you guys will remember this, but he finishes in the dark. He runs up the 18th hole in the dark.
I remember that.
Okay. All right. So Roger Meyer was the superintendent there. And the first phase of what we did was prior to that PGA event. And it was very selective. It was the very beginning of the 9th fairway. Eventually the entire 9th fairway got done. But in this phase, it was beginning the 9th fairway. I think 7 was in there. And the last 150 yards of the 10th fairway. Those were the wettest areas. And Roger says to this day that if we hadn't done that work, that they would have finished that tournament on Tuesday, because it rained all day Monday. But another interesting story, if anybody remembers watching that tournament, Faraday was announcing it. And on the 10th hole, it's a par 5. And Rory hits kind of a skinny 3-wood. And it lands in this flat area, this in front of the green, and skipped onto the green from probably 55 yards. Now, the entire day, balls are hitting and plugging. And
it's so wet.
Yeah, because most of the golf course hadn't been done. It was going to be 8 years before we finished the rest of the golf course. Faraday says, I have no idea. And I saw him interview Rory a few years later. And Rory, I would love to meet Rory, but Rory says, I have no idea what that ball hit, but it was the area that was drained in front of the green, and the ball released. It rolls up 5 feet from the hole. He knocks it in for eagle and goes on to win the tournament.
So are you claiming that you helped Rory win that championship? Is that what you're trying to say, Dennis? Rory wouldn't have been anybody if it wasn't for you guys? That's what I'm hearing here. I don't know if that's true or not, but yeah, you should get to know him. He should actually give you some money. I would say, His career is built on that. Now that's Valhalla is a great example. I mean, now they've done a lot of reconstruction work. Is what happens when that, when they do, a lot of regrassing, and they've moved
Zach's
a lot.
been real. I'll let him kind of go on from there.
Yeah, I think the scope of the recent changes at Valhalla was more of a regrassing and updating type. It really wasn't heavy earth moving. But no, there are cases where we've installed a system and a club decides, okay, we want to do a big renovation and move dirt. And no, you definitely have to be sensitive on where you're doing cuts and fills and basin placements and actually cutting and compromising pipe that's already been installed. So,
can you save it? Can you, I mean, if we had you come in 20 years ago or 10 years ago, whenever it might have been, and had the whole place laid out, and then we decide we're gonna come in with a new architect and reroute a lot of stuff. Is this, is any drainage salvageable?
Depends. I mean,
Yeah, I knew you'd say that, of course.
Are we lowering rims and getting down into that envelope where that stuff was installed? Are we raising? I mean, a deeper depth of installation is always better on a seepage pipe as a rule of thumb. So if you're adding material, doesn't hurt you, but different story if you're lowering rims.
We got a call this week. Some of y'all may know Brian Schweithofer up at Franklin Hills in Detroit. He's got a renovation going on. Great golf course, and he just does an unbelievable job there. He calls us up and he said, we got this, we're renovating. I forget who was Andrew Green. I think so, Zach.
I believe.
The busiest architect in golf right now. We're trying to get on this show, but he doesn't. He's too busy. So, Andrew, if you're listening, please call me.
So Brian said we're adding 3 feet, and we got this basin there. Anyway, we custom fitted him a thing so that he could drop another base. But yeah, so those grades can change. Now, if you go down 3 feet, you're gonna take stuff out and you're going to have to redo.
Talk to me about basins. I mean, you broached this a little bit, but is there something unique about what you guys are doing with basins? You said you had some patents on basin work. I mean, I'm not an engineer, and I certainly don't understand it. So
so through Dennis studies and his
work in the library at Tulane.
Right, his newfound understanding of seepage drainage as he was unrolling those scrolls.
Exactly.
What he noticed, I think,
under candlelight.
Right. What he noticed going out to properties is that most of the inlets that he saw were a piece of pipe with a grate on top, which is still conventional, designed to collect surface water. What he came up with using those same principles, seepage principles that he used to come up with turf drain, was a basin that would not only collect surface water, but seepage water as well through the sidewalls. Now, not industry, I could say industry standard again. A lot of people think they're doing this when they install a riser with a grate on it. They may use a perforated pipe as the vertical riser and backfill with gravel, but it's the same. The production, the curve dives as performance curve goes down quickly as that sediment gets in those channels. So same concept, but again, we're building a technically correct seepage system in that basin. So it's an aluminum frame basin, but it has a permeable sidewall with geotextile that allows water to come through the sidewalls. And we manufacture a round 12-inch basin that Perma Basins is the name of it. And then those channel drains that Dennis may have alluded to earlier when we were talking about collecting up a watershed are a wider basin, a narrow and wide basin that are designed more for streaming flow. But again, they're a basin that was designed to collect both surface and seepage water.
And both of them are made in kits. So the round basins are made anywhere between 2 and 8 feet deep, depending upon as Zach mentioned, we classify the seepage water into 3 different classifications. We want to collect different depths depending upon which type of seepage water it is. But you take the same frame, but we sell you a different kit so you can put these different depths in. The channel drain comes in a kit where you build it to the width of the stream. So we identify how wide that stream is in a different part of the golf course. So you may, it's an 18-inch module. And so so like a channel 2, we call it, is 2 modules and it's 3 foot wide. A channel 3 is 4.5 feet wide.
And that would be determined based on the flow of water across that area and the soil type, I assume. I mean, everything is unique to the property.
That's during the planning process. We pick which models.
And Joel,
Go ahead, Zach.
not to redirect the conversation, but I think you may find this an interesting aside, just kind of design philosophy, what you mentioned basins. What we're seeing is lately there's been a trend with more and more designers, and I think it's a harkening back to the golden age, more minimalist philosophy of using less less pieces and parts out on the property and having it look more natural, that we see some designers now want to use less and less and less inlets in play areas and in turf areas.
Right.
And I think this is more of a aesthetic and artistic choice. They're
Playability.
right. Guys think that balls are gonna roll toward basins or land on basins, and
I shoot
if
for basins because the ball bounces a little bit
right,
further.
right,
Get another 20 yards.
right. But that same concern I don't think has been applied to irrigation heads. If you look at the amount of square footage that irrigation heads
They're growing.
cover on a golf course relative to inlets, but the point I wanted to get across here is we mentioned surface water and seepage water. You cannot beat the volume of water that you can collect with a surface inlet, getting it into a pipe and getting it off the turf.
Right.
The seepage water that you can collect is fractional compared to surface water, though the cost to install seepage components is exponential relative to installing the surface component. So bang for your buck in performance, the more water you can get off with a surface collection component and the less footage across a turf area that water has to run, the less it can saturate.
Yeah.
So what I'm trying to get across is I think maybe memberships overlook that to get a golden age, a classic look to your golf course, there is some give back there. Mr. Ross didn't put in a bunch of surface inlets, but Mr. Ross wasn't mowing greens down to these ungodly levels that, that superintendents are able to do now. And so there's a give and take there. Designers, they have to balance art and science. That's their job. But we think, because we're drainage nerds, that the more water you can get off in an inlet, the better a property is going to perform. And some of the big projects that we've been involved in recently have leaned more heavily toward a very involved seepage system because there weren't as much inlets present. But this has a cost and performance, effect.
Are you guys working with?
Zach and Richard were very involved. Richard Lukens, our rep in Houston, Texas, were the main guys that worked with the new PGA Frisco project on the Gil Hanse course. And
beautiful property. We've been on there.
Yeah, so that one was because that's what Gil wanted, was basically no inlets. It was primarily a seepage system, and so it had tremendous amounts of seepage drainage relative to a golf course that would have had a different combination, but that's what he wanted, and that's what we tried to do.
And also, we've had people look at some of the images and seen the intensity of the seepage fields that we have in the fairway there and said, good Lord, this is crazy. That's overkill. But this is a property that's going to have professional tournaments, probably major championships, possibly a Ryder Cup one day, in the wettest stretch of the year in Dallas. So,
and they've been very wet this year. I mean, it was horrible.
Well, summer was quite dry, but earlier, I think they did have some.
But they had a couple.
But that's what we try to design for clients' goals. Like I said, there's no one size fits all. If you're having majors, you need a different seepage system than the municipal course does.
How closely do you work with architects, and who's doing the actual initial design when it's new construction? Is it the architectural group, or is it you guys? Or
I mean, so what I mentioned before is that most of our work is on existing golf courses. I think because of the recent economic situation, new construction's been kind of back online to some degree, and it's a little different modus operandi for us, and what we did at Frisco and what we're mimicking on other properties. The designers are going to shape what they want in the field, and they have an idea of where they're going to get surface water to go. Generally, from a storm system standpoint, there's a civil engineer involved in new construction, concerned with the big volume of water, getting water collected, getting it off the property. But when it gets to the more nuanced fairway drainage, that's where we come in. In Frisco, what the sequence was there was a mass grading done, and then Gil and Jim Wagner, they do shape, them and their associates do all the shaping of the earth. So once their shaping was complete and they blessed the hole, then we went in and we manually laid out the drainage system. So the angles of a seepage system we feel are critically important as to the efficiency of how things get collected. But anyway, we actually paint on the ground, where every seepage line was going to go. And then the contractor, in that case, it was Heritage Links, came in and did the trenching and backfilling and installation.
So you're actually coming into new construction after final grade, after the architect has signed off, and then messing up their work a little bit, and aren't they?
Yeah, I mean, we never want to. We don't want to
sensitive about things like that.
Yeah, but I mean, we're just trenching, putting the pipe in and putting it back the way it was. And regardless of whether it's new construction or working on existing properties, we rarely ever want to move dirt to drain a golf course. We think we can do it without moving dirt.
And if you go to your website, you guys have some great pictures of fairways. And I mean, it looks massive to me when I first looked at this the other day. I mean, there's a couple pictures you have on your website of fairways. It's a herringbone that looks like it goes on forever. And is that typical, or is that based on the soil type? I mean, it just seems like a lot of stuff.
Let me talk about that a little bit, because actually I was just, what Zach was talking about was the angles.
Right.
One of the things I think people will find interesting is that we probably lay out the angles differently than pretty much anybody else. And in fact, we really don't use many herringbones. So herringbones typically would be an alternating lateral line coming in at usually a 45-degree angle. It's very common in greens construction. Yeah. The reason it's done is because your lateral line is working downslope. It makes it easy to shoot. You don't have to shoot as many elevations. With our system, I'm not saying we never use herringbones, but we're trying to get as close to 90 degrees to the flow direction as possible. So because you cover more square footage with linear feet of turf drain. So if I laid out a circle on a map and showed you a 45 and how we could cut off square footage, I can cover more square footage with less drainage if I can get perpendicular. Now, what that involves is a lot of flag patterns, or sometimes we're asking the contractor to buck grade over some slopes and that types of thing. But one of the, I think the most valuable things that we provide to our customers, not only do we do the planning, but during the construction, we stay with the project throughout. So it may be for 7 or 8 years. Every time there's a construction phase, somebody from our operation comes on site and literally lays this out. So when we do the plan, we give them a mapping of the basin sites and the transportation pipes. We don't put the seepage drainage lines on there because we give them a budget for that. We don't know until the day we lay it out, because we have to wait until they paint their irrigation, utilities, all that out. Then we match up that to the flow areas and the directions to get the best angle and get the most square footage per linear foot of turf drain. So we have every type of pattern. There are areas where we have things coming in at 45s, 90s. We do reverse angles. Sometimes we can get the most square footage, and we're also trying to give the contractor the way that he can get the most pipe in the ground for the least number of man hours, so that it's the most efficient way. And all those things are dependent upon how the system's laid out.
And a lot of that is because of the design of turf drain itself, is because it's
it's very horizontal. Very easy to do reverse angle with turf drain. You can do it anywhere from 180 degrees.
And I think if somebody's listening, they don't know this particular product. I mean, take a look at the website. There's some really very good pictures of what turf drain, the product, actually looks like, and you can see very clearly the distinction between that and perforated pipe. I mean, it just looks on paper anyway that this is going to gather a lot more water and stuff. What happens after you guys are done? And now I assume the channels are all filled up with sand. And now I'm going to talk again self-servingly. I'm now the superintendent, and I got all these lines in the middle of my fairway that are full of sand, and then I got soil, and that's changing the color of my grass. How do you address that?
2 different types of sands are used. So the first sand is a coarse sand with our specification calls for a perk rate of minimum of 30.
First sand is up against the turf drain?
Yes, and it goes down to the bottom of the trench. So we may be digging we work mostly between 2 and 6 feet deep. Sometimes we get to 8, but our trench lines, whether it's 2 or 6 feet deep, we're going to compact that coarse sand down to about 6 inches below grade. Now, then we come in to the top of it, and we use a mix with a moisture retention, typically about 18% moisture retention. Now, the droughtiness that you're going to have in a line after an installation is that differential. So there's not a magic number of moisture retention, because it's how much difference is the moisture retention between the native soil and the drought and the drainage line.
Right.
But we try to get enough moisture retention in that upper 6 inch. And honestly, we don't care what the infiltration rate is of the upper 6 inches, because we could put asphalt on top of that upper 6 inches,
because you're getting it laterally.
We're designing the system to get the surface water off through surface collection.
Gotcha.
What we're collecting with the seepage line is water that's in the profile that we couldn't get with surface water. It's one of these 3 types of seepage water. So we don't care if it has low permeability. We'll never get to the point where you may not have some droughtiness, particularly in the first year or two. But we tried to reduce that by using this mix in this upper 6 inches.
Go ahead, Zach.
No, and we found that's the best way to combat it, getting that mix in there. We have had some superintendents that have opted to use coarse sand all the way to the side line, but that brings in a maintenance practice of using a wetting agent on a routine basis, at least until organics build up in that layer. But I think when you go to a property and you see a ton of drought lines everywhere, the issue is generally that it was backfilled with either sand all the way to the top or just gravel.
I never realized that you don't care about the water going down that line. So putting asphalt is obviously absurd, but it would also, I mean, this is going to be very self-serving, but I'll say it anyway. We put a lot of things like Renovate Plus and Zeolites, things like that into those lines, because we're trying to mimic soil and give, some not only moisture retention, but an ability for microbiology to, microbiology obviously is much weaker in sand lines than it would be in the soil. And we're trying to mimic that soil. So those types of practices, putting down, amended organics, minerals, that wouldn't affect your process.
No, and we're fine with using some of those things besides just regular peat and that type of thing.
I'm glad I asked you that.
That's
always a little nervous.
It can just depends on what their supplier,
Right.
Whether they're going to mix it on site or off site, or if they're going.
But even if they apply it after the fact into that sand top inch, it's not affecting the drainage at all.
Oh no, it's not going to hurt the drainage at all. So yeah, that's fine.
Yeah.
One thing that we didn't mention when we were that Frisco project in particular, and I think some of those images with those massive seepage systems may have been what you were talking about.
It might have been Frisco, yeah.
Yes.
I might have seen it on
another caveat to what backfill material to use, or at least in the top section, is, are you sand capping or not? Sand capping brings a totally different conversation.
Of course it would. Yeah.
We won't get that. That's a long drawn out.
Yeah, let's not go there. That's too much.
And let me mention again, I've said this a couple times about these webinars we have, but one of the webinars we have that I do think people will find interesting, it's not as technical, but it's like concentrations of flow. It's really understand. It's a simple concept, but it's critical to understand. One of the webinars is the inherent differences between surface and seepage water. In that webinar, we go through all the things that you need to do and why we want to classify each area as to where it is on this scale of, you almost never have 100% surface water problem, and you almost never have 100% seepage. So where is it on the spectrum? How much is surface? How much is seepage? What the differences are, where the design is changed depending upon whether it is surface or seepage. But I won't get into all those details, but it is available on that website.
You got a lot of these on TurfNet, I understand, right? I saw them.
Yeah, and they're on our website also. So the TurfNet lets us link to them on our main page. Yeah. Down there in the bottom left. It is a TurfNet video, but it goes straight to the link.
Yeah, Peter's the turf nut, by the way, and we had him here on the podcast a couple of times recently. So yeah.
Hey Joel, I think one of the things that you may find interesting and your listeners may find interesting, Dennis, if you talk just as briefly as you can about aerifying in fairways and how that relates to how some guys may think of drainage. And the differences between aerifying a green and aerifying a native soil fairway.
Oh yeah, it's always a pretty interesting discussion with superintendents, and you know, I, but it's the physics of aerification. So aerification is ideally used, for instance, in a green where you have a layer and you penetrate through that layer and you reconnect to that permeability of that higher permeability layer to get water through. But when you aerify a low permeability fairway with, let's say, a deep tine aerifier or any type of aerifier, you pull that core. So it's like going out in a parking lot and taking a cup cutter and cutting in concrete. When it rains, the last place it's going to dry is going to be that cup you cut, because your airspace, the highest permeability, is you've filled up your airspace and you're surrounded by the lower permeability. Yeah. Well, same thing when you go into a clay fairway. You can't aerify a clay fairway to drainage, because what you do is you change what's called the runoff coefficient. So every soil and property has a different runoff coefficient based upon slope and permeability. So these are on tables that we can plug them in. But the basic concept is the lower the permeability, the higher the runoff coefficient. So if your fairway was asphalt, you'd have 100% runoff. You wouldn't have any seepage water problem. You'd collect the system as a surface water system, just like you do in a parking lot. But in turf, you don't have that 100% runoff coefficient. The lower the permeability, the higher the runoff coefficient. So a clay fairway has a higher runoff than a sand fairway. But if you go into a clay fairway and you aerify and create these holes, you've changed the runoff coefficient. Yeah. So now you've actually now people get temporary relief after these aerifications, but in general, aerification, you'll never aerify your way to solving a drainage
You're not
problem.
Getting rid of water running across your fairway. You know, it's funny. You guys are, I say this in all of the classes that I teach, but probably the most important nutrient in turf is oxygen. And you can't really, I try to sell people 275-gallon totes of oxygen, and nobody has bought one yet, which is kind of funny. But interestingly enough, you guys are selling oxygen. I mean, think about it. What you're doing is, you know, you're getting rid of water, it's leaving oxygen, and it's the single most important nutrient in the overall. And I know that's a little flippant, but it really is, right. You know, without oxygen, it's the first limiting factor. You got no oxygen, you've got no anything. I tell this story in all of my classes, and it's a true one. And I just still to this day find it amazing. I asked my class when I was teaching at Rutgers, how long can we go without water? And it's a couple of days. And I said, how long can you go without oxygen? And the guy in the back room raised his hand and says, I don't know, about a day. And which is always a good chuckle. But you guys are providing oxygen to your clients, which is hands down the starting point of everything that we do in this industry. I hate to say this, gents, but we are running up against the clock here. Is there any, I mean, not that I'm trying to bring up anything negative, but what's the downside or what could go wrong, maybe, is a better question when somebody does a drainage problem? I mean, what kind of advice would you give to somebody, a superintendent that's looking at doing this to prevent any kind of real disaster? Where's the really scary part of this?
Well, I think the important thing is don't spend a lot of time and money and not have the proper results. So we have a saying that we don't put anything in the ground 12 to 14 inches deep. We say save the gas in the trencher. If you're collecting seepage water, the lower the permeability, the deeper the installation has to be. So where you can get by with a relatively shallow installation in a greens construction is because you have a known permeability in your mix. You got a gravel blanket, and you're getting by with a 12-inch mix. You can't drain seepage water out of low permeability soils installing pipe 12 inches deep. So our whole probably thing we really have brought to the industry, other than the turf drain, is the way to go deep and get this seepage collection. So we patented the siphon system, which is the first system where you can install drainage without having to grade pipe. And the purpose of that is so that you can get these relief points, whether it's a coastal property or just a property that you can't get self-cleaning velocity on a gravity pipe because of the distance of the relief.
The shortest way to wrap that all up is when you're draining surface water, it's about pipe size and slope. When you drain in seepage water, it's about depth of installation and airspace at that depth.
So how do you have a siphon system that works without a grade pipe?
It's patented.
Well-
We can't tell you.
Good answer.
So the siphon is the same as the gravity in that it could only move water to a lower elevation. The difference with a siphon is that it can move up over elevations. So you don't have to grade the pipe. It can move water up to 1 atmosphere as the atmospheric pressure will push it up and over a hump. So where we use it mostly is when you have long runs of gravity pipe. Again, in our presentation on the differences between inherent difference between surface and seepage, one of the keys between surface and seepage is surface water, when you collect it, always has contaminants. The water comes in through the
Right.
opening. You got clippings, silt.
Sodium.
And when you have contaminants get into the system, if you don't have proper velocity on your transportation system and you put it in a pipe on too flat a grade, that system's going to fail over time. A seepage system never has contaminants if it's built properly. It's a stable system. But when you can't get self-cleaning velocity for the surface contaminants on a system, the siphon can be put into that same installation, same elevation changes, but we hook it up. It uses HDPE pipe, which is common in irrigation now. We started using HDPE pipe back in the 90s because we found real quickly you can have a small leak in an irrigation system, but there's no such thing as a small leak in a vacuum. So we use HDPE pipe connected to the irrigation system. You can put that on a clock and flush it once every 2 months, blow these contaminants out. You can put a system in a floodplain where a creek comes out of its banks and deposits sand into the basin, and you can completely blow the system out with the pressure of the irrigation system.
Does sodium affect any of these systems? If you have a soda brackish water anywhere?
No, but I mean, one of the key, in desert areas and low rainfall areas, one of the main things we use drainage for is to be able to control salt so that they can go in
So they can irrigate
and
them,
flush. And they have a way to
brilliant.
get that excess water
Yeah.
and move those contaminants off there.
Well, gentlemen, I hate to say this, but I'm up against the clock and they yell at me
It's
if I
been
go
great.
over.
We've
But,
enjoyed it.
Dennis, I can't thank you enough for coming and explaining this to me and letting me get on a float. And Zach, it's a pleasure. And I assume that you're going to be the future of this business. I hope, right?
If there is a future, yeah.
I'm sure. I think there will always be water problems. And it's funny. I was on the golf course today and locally here, and golf is up and people are playing and I think that I think we have a good future. And Dennis, if you can keep helping some of these guys win major tournaments like you did with Rory, I think you've got some stories or at least a book to tell. But
yeah, Zach's doing a great job, and we really appreciate you having us on today.
Yeah, we
Absolutely.
thank you very much for your time. We think, drainage is kind of the least sexy, but most important part of the golf industry, and maybe the least understood, at least some of the
it's
nuance
oxygen,
around.
babe. I mean, it's the most important nutrient you got in turf. So you gotta pay attention to that first, or you got nothing. So
Right. But
so
we're nerds and we could go for hours upon hours. So
maybe we'll do it
thank you
again.
for your time.
It could be a lot of questions. Maybe I'll get Kevin Hicks on next time, who actually understands this a little bit better than I do. But anyway, thank you both very much. And I want to thank everybody for watching. And this is the Earthworks podcast. If you're not a subscriber, please subscribe, because we try to have fairly interesting folks on like we did today. And we'll be back again next week with another Earthworks podcast. So thank you very much. Thanks,
See
guys.
you in Orlando.